Okay, so we talked about this to start with, and we recognized what all these inverses were. We recognized, you put your shoes on, take your shoes off, right? That they're inverses of each other, right? My pen's broken, so I got to use my finger. Dirty plate, talk about cleaning the plate. They undo each other. Add the opposites here. Pretty straightforward. Okay? And then we talked about the square root. We never did talk about the last one, though. If you raise something to a third power, in other words, you cube it, what would be the inverse of that? It'd be called not the square root. It'd be called the cubed root, and we write it like this. Now, we won't do much with this in Math 1, but you will a lot in Math 2. You'll do a lot of cube roots in Math 2, so we'll get to that for next year. All right, I want to look down here at the bottom. If I take an original number, 27, I reach up into the cabinet, I pull out a 27, okay? 27 is a nice, pretty number. It's brand new. I haven't messed with it a bit, okay? Beautiful 27. I take that 27 and now I'm going to customize it.
Okay.
So I add some 5s to it.
32.
Okay? When I add 5, what do you get?
32.
Everybody agrees you get 32, no problem, right? Okay? But remember, that's no longer 27, is it?
No.
You took a nice, pretty, regular, mint condition 27 and you changed it by customizing it by adding 5.
Yep, now you have to subtract
Okay.
5.
Well, you change your mind. And let's say, hey, I don't like it with the 5. How do you get it back into its original condition? All right, you have to do the opposite or the inverse of what you did the first time. And of course, what do you end up with? You end up with 27. You end up with exactly what you started with. And that's the whole point of the inverse. The inverse undoes what was previously done to it. Okay, so I have some mystery number in a box. I reach up into the cabinet. I pull out a box that has a number in it. Now last time I pulled out a 27. This time I don't know what's in the box. But I do know that somebody else has already customized this box. Somebody else has already taken this box and multiplied that box by 4. And when they did, they got 36. So it's my job to figure out what number was in the box.
36 divided by 4.
Okay. What did they do to customize this box? They multiplied it by 4. So what do I have to do to undo that? I have to divide both sides by 4, right? And then I find out that the box has to be a 9. And I think we all agree it's a 9. Someone else has already taken this other number x and they've customized it. And what they've done is they multiplied by 5 and then added some 3s to it. Really tricked it out. And they've taken this mystery number, x, and they've made it their own. And they say it's now a 63. I don't like that. I want to undo what they did. So can we figure out what the mystery number used to be? Undo what they did. Think about how to undo what they've done. Let me rephrase that. Let me say that again, actually. They've done 2 things to this number, right? They, like we were putting on socks and shoes. They put on a sock, which would be our multiplied by 5. And then in addition to that, they put on a shoe, so adding 3. So in order to get the shoe off, you have to take the shoe off first and then take the sock off. So we have to get rid of the 3 and then the 5. This is what it would look like math-wise. They took some mystery number x, multiplied it by 5, made it 5 times bigger, and then added 3 to it. And when they were done doing this work here and tricking it out, they ended up with a 63. So, like he just said, undoing all of that, take the shoe off, which is minus 3, and that gives us 5x equals 60. And now I can take the sock off, which is divided by 5, and we do find out that x is 12. So we're going to start off with this x plus 7 equals 12. Hopefully it's an easier example to kind of get started. I've got some number x that I've pulled down off the shelf. Somebody else has added 7 to it, and when they did, they got a 12. That's what they did to customize it. I want to undo what they did. I want to return it back to its original condition. What can I do to undo what they did? subtract 7 from both sides, right? I'll subtract 7 from both sides. What do we normally say happens with this 7 minus 7?
It goes away.
Okay, a lot of you say that it cancels or it goes away. Really, 7 minus 7 is 0, and it does kind of disappear. That leaves me with x equals 12 minus 7 is 5. How do you check your work?
5 plus 7.
Yeah, you could plug that back in up there and check that 5 plus 7 equals 12, and of course it does. Somebody else has already taken your magic number, your mystery number I mean, x, and they've done some work to it. They took your x and they subtracted 9 from it. After they subtracted that 9, they ended up with a 20. So you've got to figure out what that mystery number used to be. If they subtracted 9 from it, how do you fix it? Add 9. How do you change it back to its original condition? You're going to add 9 to both sides. And what do we say happens with the negative 9 and the plus 9? They end up being 0. So x is equal to 29. And you can check that by plugging it back in, right? Everybody remember doing this? There's a little bit more details to this one that we will cover later in the year. But for right now, just the bare bones of it, I want to know somebody else has taken this letter x, this number x, and they squared it. And when they squared it, they ended up with 121, right? How do we undo what they did? We take what they did. This is what they did, right? We take what they did and we do the inverse. That means we square root both sides. And we simplify from there. Now this step is important. I want to make sure that we write down this step here, that we write down the square root of x squared. The square root of x squared always inverses each other and you end up with an x. But it is going to be important for us to be consistent that we write down this step right here. A lot of us like to skip that step. We're going to want to write that one down every time. Now, technically, it's plus or minus 11. We'll talk about that later this semester. A couple of you got it up front and you said it fine. This reads x divided by 5 equals negative 8. So clearly, it's easy to tell that someone else has taken my number x and divided it by 5. We will do the inverse of that, so we will multiply both sides by that 5. And this 5 and this 5 will go away because multiplication and division are inverses. And that leaves me with x equals, what is negative 8 times 5?
Negative 40.
Negative 40. And of course you could check that.